Hello everyone, I am Soumyashree Senapati, Assistant Professor of Civil Engineering at Vedang Institute of Technology. So, as we are understanding about shear force and bending moment, and in our previous class we have discussed about beams and classification of beam. As we are calculating shear force and bending moment using beams only. So, to understand the concept, we need to draw beam and put some load there. Okay. So, let's start. Here we have taken the beam A, B and applied load at P1, P2 and P3. Okay. Also we have laid another UDL, uniformly distributed load, as W1. Okay. So now to understand how to find out shear force and bending moment, let's take it as case 1. Okay. So let's here this beam as only simply supported beam. We have taken the beam and the supports are simply supported beam. Okay. So first we need to free the beams. So to free, we just need to what? First we need to replace the supports with the help of reaction forces. Okay. First, before calculating shear force and bending moment, we just need to put reaction forces. Okay. Right? Here taken RB and this we will take as RA. Okay. Reaction A at A and reaction at B. And the loads will be same. If there is UDL, you can draw like this, also like this. So, P2 and P3. Okay. Now, we will just calculate shear force and bending moment at a section. Let's take it as X's and name it as C. Okay. At point C, we will find out shear force and bending moment. So, to find out shear force, we just need to go to the definition of shear force. In our previous classes, we have already discussed what is shear force. Shear force is the what? Summation of all the unbalanced forces. Okay, summation of all unbalanced vertical forces from right side or from left side, from left or right section, right to the section. Okay. So, if we are calculating shear force, what we will do? We will do nothing, just separate the sections from here. Let's, here we have one section, that is A, C, and another section will be CB. Okay. Now we will find out shear force. So, other things will be remain same. Here are A and P1, UDL W1, but Let's assume the shear force here at point will be in downward direction and name it as V. Okay. So, next in this BC section, what will happen? P2 and P3 will remain same, and here we have our B. Okay. So, as we know, summation of Fy is equal to 0. So, here we are getting B in downward direction. So, to nullify the whole effect, we will have in BC section, we will have B dash in upward direction. Okay. So, to find out shear force, we just need to separate the section. Okay. So that we will calculate shear force. Now, to find out what? To find out bending moment, just similar process, and we know the definition of bending moment. Bending moment is what? Summation of all the moments with at any section right or left to the section. Okay. The very similar process and the same drawing here. So, here that the definition says summation of all the moments. Summation of all the moments means movement will be what? Force into perpendicular distance. So, here we will have movement in anti-clockwise direction. Okay, let's assume the movement will be in anti-clockwise direction. So, in BC section, this will be clockwise direction. Let's take it as M, and here it will be M dash. Okay. So, as here we are having anti-clockwise movement, just to occupy those, here we will have another movement like this, and in this section we will have like this. Let's draw again this AC section. Okay, and we are having downward shear force here and anti-clockwise movement, that will be termed as capital M. Okay, the loads will remain same always. Here the uniformly distributed load, that is W1. So, as we are having the shear force here in downward direction, we will have the external load that is in this direction, or you can say in upward direction. In similarly, in CB section, okay, C and B, the very similar process, as we are having the shear force in upward direction. So, we will have the external load in downward direction. Okay. So, also here we are having M dash, that is clockwise direction. Now, the shear force will be like, you can see the external load will act like this, and here in this section 6. Okay. So, you can see the external force is acting in clockwise direction. So, you can say the clockwise force will be positive of what? Shear force. Okay. So, let's take this AC section. In AC section, we are having anti-clockwise what? Anti-clockwise movement. So, here we will have clockwise movement. Okay. So, if the movements are acting like this, there will be the beam will bend like this. The beam will sag. Okay. You can draw like this. The beam will sag. This is called as sagging movement. Okay. And sagging movement is always positive. Right. So, another if this is acting what? Clockwise direction. Now it will act anti-clockwise direction. And here this is acting anti-clockwise, so it will act clockwise. Okay. Because of this type of reaction, it will start hugging. And this movement is always negative. This movement will be termed as hugging movement. Okay. Now we know what is sagging and hugging movement, and we know sagging is positive always and hugging means negative. Okay. So, here we know the sign convention part of shear force and bending moment. If forces are acting what? Clockwise, then it is positive. And if the forces are acting like what? Anti-clockwise. Anti-clockwise forces will be always negative. Okay. Now we know the sign convention part of clockwise and anti-clockwise type. So, here in this diagram, we just need to always remember this part if we are solving shear force and bending moment. Okay. This part is the most important section of shear force and bending moment. So, if we solve one example, we will understand better. So, to understand, let's have one simply supported beam, and here point load, that is P1. We need the length. Okay, the whole length is L. Here it will be L by 2 and by 2. Okay, here simply supported beam. From diagram, we will understand what type of beam it is. Okay. In our previous class, I have already discussed what type of beam and how to, what are their specifications. Okay. So, to solve this, what to do? Let's start. As I have already said, now just need to free the beam and put the reaction forces. Okay. Example 1. The question will be calculate SF and PM of simply supported beam when point load is acting middle of the beam. Okay. In our exam, we will have only the question, this part, and we need to draw the diagram. So, to calculate shear force and bending moment, we need to find out the reaction forces. Now, we will understand how to calculate the reaction forces. Okay. So, let's draw the reaction forces. Here we will have RA and RP, and the point load will be T. Okay. So, we know summation of Fy is equal to 0. So, we will have what? RA plus RB is equal to P. Right? Now, summation of MA is equal to 0. Let's take summation of MA is equal to 0. As we are taking the moment at what? At point A. So, at point A, movement will be 0. Let's start from this side. So, we are having RB into L, okay, minus P into L by 2, okay, RB into L and minus P into L by 2 will be 0. So, RB into L is going to be PL by 2 and RB will be what? P by 2, right? That means we are having the reaction here P by 2. So, we have the equation that is RA plus RB equal to P. Let's put the value of RB here to find out RA. So, RA is equal to P minus P by 2. P by 2 is nothing but your RB value. Okay. So, RA is also going to be P by 2. Okay. Now, by method of section, we will have, or we will get the value of shear force and bending moment. So, let's draw this side and here. Okay. Okay. So, to understand shear force, how to find out shear force, let's just here take it name as D. Okay, now we will cut the section BD to X, right? BD we will cut here to X and we will find out the shear force and bending moment here at point this, and we will cut AD with X section, okay, and we will find out the shear force at this point, right? So, in section let's take section BD first. Section BD first. Okay. So, listen carefully. Here we will have, let's place the shear force we will have in downward direction and the movement will be anti-clockwise. Okay. So, in section BD, to find out shear force, what we will have? This shear force, let's take it as Vx. Another force is here, you can see, that is Rb. Okay. So, shear force will be what? Vx plus Rb equal to 0. That does mean Vx is equal to Rb. We have already find out here. Here we have Rb as P by 2. So, Vx is equal to minus of P by 2. You can see the whole P by 2, that is totally dependent on force. So, at any section D to B, we will have the same value of shear force, that is minus P by 2. So, VB will be minus P by 2 and VD will be also minus P by 2. Okay. VB and VD nothing but your shear force at section B and shear force at section D. Okay. Now you have shear force. Now at section BD we will find bending moment. Okay. To find out bending moment, how to find out bending moment? Bending moment is nothing but force into perpendicular distance. So, as in case of movement at B, okay, let's just start mx, okay, mx plus what? The forces will be Rb is equal to P by 2, P by 2 into x. This distance is x. Okay. So, P by 2 into x. We can write P by 2 into x. Okay. Is equal to 0. So, at point B, moment at B will be, you can see the distance here is 0. So, the moment at B will be 0 and at point D, the distance is L by 2. The distance is L by 2 and you can see the force is here, but RB, and it is acting in this direction. that is anti-clockwise direction. Okay, so it will be positive, that is into P by 2. Why P by 2? P by 2 is nothing but your RB value. So moment at D, MD will be PL by 4. Okay, no issues. Now section, let's take section what? Section AD. So in section AD, here from this let's take the distance as, this distance take it as x. Similarly, the Vx, take the shear force as Vx and anti-clockwise movement, that is Mx. Okay, the very similar process. So as we are what? Find out first, find out SF. Okay, to find out SF, here we are having one reaction force, that is Ra. In this case, what we will have? Vx, okay, Vx minus Ra is equal to 0. Why? Because this is in opposite side and the sign will be changed in this case. Okay, so here we will have Vx as Ra. That does mean we are having V at A will be what? P by 2 and P at point D. Section A, D we are finding out na. VD will be P by 2. Okay. You can see in this whole section we are having only this. Okay. Here we are having Vx plus Ra minus point load P. Okay. The answer will be same, but there will be little bit change, that is Vx plus P by 2 minus P, that is 0. So here we will have Vx minus P by 2, that will be Vx is equal to P by 2. Okay. Next, and we are having Va as P by 2 and Vd as P by 2. Next, to find out bending moment at section what? At section AD. Okay. So at section AD we are having two forces, one is P and another one is Ra. Okay. So here you can see moment at section A. Moment at point A will be 0, as there is MA is equal to 0 because the distance is 0 here. But here at point, from point D, this to this is your nothing but L by 2 and load is what? This to this is Ra into L by 2, that will be P by 2 into L by 2, that is PL by 4. Okay. So moment at D will be always PL by 4 and that will be positive. So next to draw SFT and BMD. Okay. therefore, to draw SFD and BMD, we are having VB here, BD, and VA and BD also here. Let's just point out those. VB is minus P by 2. So, at point B, here we are having P by 2, that is minus, and VD, that is also minus P by 2. Okay. So, VD is minus P by 2. Let's take it here. Okay. So, another is VA as P by 2. And VD is also P by 2. So, now we are having the SFD drawing. Let's join all those points. Okay. So, this whole part is your SFD. Okay. This whole part is your SFD of acting of point load in case of simply supported beam. To draw bending moment, draw it here. Okay. To draw the bending moment, we are having bending moment at point D only. Okay. We are having D only, that is PL by 4, and that is also positive. And moment at point A and B is 0. Okay. So, the value will be here, that is PL by 4, and here 0 and 0. Okay. So, the bending moment diagram is going to be like this. Okay. Here, this part is your bending moment diagram, and name it as BMD, and here we are having SFD. So, in this way, if there is the value of any value we are having for P, we can find out the SFD and BMD in this way. Okay. So, in this class, we have understand the concept of shear force bending moment, and we have solved one example. In our next classes, we will solve a lots of numericals on basis of shear to find out shear force and bending moment. So, to know those methods and how to find out, we need to stay tuned. Thank you so much.